Welcome friends and welcome to my series of video lectures on design of RCC structures. We are studying chapter 1 fundamentals of reinforced concrete. This is video lecture RCC 1.2 structural design and IS course. For best video quality, watch this video lecture on laptop or desktop with resolution set to 1080p, that is HD. Expected learning outcomes from this video are 1. To describe fourfold role of a civil engineer. 2nd, to appreciate significance and role of Bureau of Indian Standards. 3rd, to know the IS codes relevant to RCC. The contents of this video lecture are 1. Process of structural design. 2nd, BIS and relevant Indian standard, that is IS codes for RCC. There are some key words or key terms used in this video: planning, structural components, structural design, rehabilitation, BIS and IS codes, IS 456-2000, IS 875. Friends, we have our best friend Smarty here with some tips. While watching this video lecture, write down your own notes. Pause or rewind the video whenever required. Do solve the formative and summative assessment quizzes in this video. Friends, in this part of this video lecture, we will be studying the process of structural design. A structure, as we know, is an assembly of components constructed for a specific function. A structure, as we know, is made up of various components. Out of those components, some components are called as structural components. What is the meaning of structural components? Structural components are those components of the structure which participate in the load transfer mechanism of the structure. Example, for a building structure, slabs, buildings, columns, footings, staircases, etc. are the structural components of the structure. They take part in the load transfer mechanism. They may not have directly a function as far as the user is concerned, but they are participating in the load transfer mechanism. The other types of components other than structural components are called as functional or architectural components of the structure. These components are non-structural. That means they do not take part in load transfer mechanism of the structure, but they provide functionality to the structure, or they are directly related to the purpose for which the structure is designed or constructed. So, example in case of a common building structure is walls, doors, flooring, plasters, paints, etc. So, all these are functional or architectural components of a structure. Now, structural design is related to structural components and not related to functional or architectural components. The world of civil engineering. A civil engineer has got a fourfold role. That means a civil engineer has to perform 4 roles. They are planning, designing, constructing, and maintaining a structure. Out of these 4 roles, planning and designing usually takes place in the office, whereas construction and maintenance obviously is going on the site. Now we will consider each role in a greater detail. First role of engineer is planning a structure. At the end of this role, an engineer will provide an architectural plan of the structure. An architect is usually doing this particular role. So on a broader in a broader sense, we can say that an architect is also a part of civil engineering family, obviously, and an architect is doing this planning of a structure. An architectural plan of the structure is a plan showing the decisions related to arrangement of functional components of the structure. Functional components, as we have seen, they are the components which are directly related to the purpose of the structure. For example, for a building structure or an apartment structure, living room, bedroom, then the kitchen, and all these are the components or the areas of the structure which are architectural or functional components. So an architectural design means deciding the arrangement of functional components of the structure subject to standards and bylaws to serve desired purpose. The architectural design has also to take care of the rules and bylaws of the government or the corporation in which the structure is going to be designed, and it has to finally focus on the desired purpose of the structure. So this is the first step, that an architectural plan of the structure based on its functionality subject to standards and bylaws is to be prepared in the first step, that is of planning. You can see this typical plan where you can have that bedroom, living room and all those things, doors and windows, where the stair will come, and they are showing roughly the layout of the furniture also, which probably the user may be using. So this is all about the planning of a building structure, followed by structural design. We can just convert this architectural plan or architectural design into structural plan. The process of structural design begins here. So what is the output of structural design? Just as output of planning of structure was architectural plan, like this, the output of structural design is finally structural drawing for actual construction of the structure on site. What is the meaning of the term structural design? Structural design of a structure means deciding materials and configurations and dimensional details of the structural components. We have to note here that we are now talking about structural components of the structure, whereas we talked about the architectural functional components of the structure in the first step. So second step is related to structural design. So structural design of a structure means deciding materials. We have to decide the material also. Are we going to use pre-stressed concrete or steel or RCC, or what type of material are we going to decide or use? That is to be decided. Secondly, the configurations and dimensional details of the structural components, that is that slabs, beams, columns and footings and stairs, they are to be decided as the outcome of structural design. Now, because we are studying structural design, we are going into little more detail of this structural design process. So the structural design process actually has got two steps. One is called structural analysis and second is called actual structural design. In structural analysis, we have got two parts. Suppose you are talking about the member of a beam. You can see a drawing here. You are talking about a beam. The beam may be here actually, and the architect will not show a beam actually. He will show a wall. But the structural designer will decide that there should be a beam under the wall. So beam is a structural component. It's a matter of structural design. So suppose that you want to design this particular beam. In that case, first thing you have to do is you have to understand its structural behavior. Understanding structural actions involved under estimated loads and materials. This is the meaning of structural behavior. So we have to understand how this beam will behave after it is subjected to the estimated loads. So that is what is called as structural behavior. In the earlier subjects of structural analysis, you have done the bending moment diagram, shear force diagram, deflection of beams, so many chapters on beams. All of them were studying the structural behavior of the beam. So the first thing in structural analysis comes structural behavior. Second thing is parameter analysis. So calculate the structural parameters using analysis theories. So what are the structural parameters? Just now I said the structural parameters for a beam are the bending moment diagram, shear force diagram, deflection, bending stresses, moment of resistance. All these parameters of a particular beam, they are to be studied and calculated based on the given loads, the values of given loads. So all these point number 1 or A, structural behavior, and B, parameter analysis, they finally give us what we call as structural analysis. After we have decided the structural parameters, after we have calculated the structural parameters, for example the bending moments, the shear forces, then we go to the process of structural design. And in structural design there are two parts. First part is deciding dimensions of components. That means you have to decide the dimensions of this beam. The span of the beam is already given in the architectural plan, but the cross section of the beam, whether it is going to be a rectangular cross section, whether it is going to be a T-shaped cross section, whatever type of cross section, the designer has to decide it, and he has to finally find out the dimensions, that it will be a beam having cross section 230 mm by 500 mm and so on. Whatever numerical dimensions the beam is likely to have, the designer has to decide finally. So he has to use some design theories for that. Just doing these calculations requires lot of theoretical exercise and theoretical insight, which is provided by various design theories. These design theories are evolved with time. So whatever you studied 50 years back, whatever theories you used 50 years back may not be working now. So you have to go for further the theories which are updated. So like this, the designer has to take care of design theories, and accordingly he has to do calculations to decide the dimensions of the components. Same is the case with every component, beams, columns, footings and all that. So he has to do all this calculation work. All this work is done in the office obviously, and nowadays we are using different softwares also to help the designer or to help the engineer to do these calculations faster. Then the second part, doing the calculations and coming out with the conclusion of the dimensions of the beams, the engineers have to transform the design conclusions to prepare structural drawings for actual site construction. You cannot send numerical calculations to the site and accordingly they will construct the building or construct the structure. For that, all these numerical calculations are required to be converted into a drawing. So this process is called as drafting. So drafting is transforming the design conclusions or design calculations to prepare a final structural drawing for actual site construction. Now you can see here there are no calculations, nothing. This is only containing the bars, the sizes and the labeling. The labeling is also, it's not academic type of labeling or theoretical type of labeling. It is all related to the details of the dimensions which the construction engineer or the person on the site will be using. So this is the conclusion. So structural drawings, after having gone through these first three steps, finally we have to come out with the structural drawing. So this was in short the second step, that is structural design. Now after structural design is over and the drawings are sent to the construction site, the role is, now the ball is in the court of the construction engineer. This is the third role of the engineer. The same engineer is there, but he has to now put himself in the role of construction engineer, or you can call him as contractor also. A contractor is a person who owns an agency in which he can appoint engineers for the execution of the engineering or the structural drawings in the form of actual construction. So the role of construction is this, that construct on-site the structure as per structural drawings. So you have to simply look at the drawing, study the drawing, no theory behind the drawing, only the drawing that you have to study. You have to study it thoroughly, and accordingly you have to actually erect the structure on site. Now contractor does the construction work. So here you can see a building being constructed, and here you can see an RMC truck where the actual construction has begun. And this is the third step or the third role of civil engineer. He has to be responsible for the construction of the structure also. And the fourth role, the last role, is maintenance and rehabilitation of the structure. Once the structure is constructed in the third step, in the third role, it will have its own life, 50 years, 60 years, 70 years, whatever. So after that or during that life also, if there are any problems during suppose the building is constructed and there is leakage, there is excessive cracking, in that case there is the fourth role of the engineer. He has to attend to that already constructed structure to remove or to handle the problems arising. For example, I told you, leakage or cracking can be some of the problems. So he has to take maintenance action. He has to analyze the problem and he has to accordingly take action for maintenance. Also rehabilitation. A structure sometimes can become so old that you can see a structure here. So it can be so old that the activity required to be done for that structure is not merely maintenance, but it is rehabilitation. It is like not demolishing the structure but almost renewing it. So that is what we call as rehabilitation of structure. So engineer has to play this fourth role also, maintaining and rehabilitation. So this is carrying out maintenance and rehabilitation activities. Now for maintenance and rehabilitation activities, some extra expertise is required, because problem shooting and problem solving and to find out correct remedies and implement them on the site is more difficult than design a structure from the beginning. So maintenance and rehabilitation, special experts are needed for these activities, but finally this is also the role of an engineer only. So we can say that the process of structural design is having 4 steps, and these 4 are the fourfold role of a civil engineer also. Planning of the structure, which gives us finally the architectural drawing, which is related on functionality. The second step is structural design, which finally gives us a structural drawing, which is related to design of slabs, beams, columns, footing, stairs, that is the structural components. Then the third is actual construction on the site, and the fourth is maintenance and rehabilitation of the structure whenever required. So these are the fourfold roles of a civil engineer, and this is in brief the process of structural design. Friends, after having studied the process of structural design and the fourfold role of an engineer, we will now consider another important aspect of the structural design, that is related to the Bureau of Indian Standards BIS and relevant Indian standard codes for RCC. We will have a little background of this topic or of this subtopic. A country-wide standardization is necessary to regulate and harmonize uniformity in quality of processes and products in every technological field in the country. So in every technological field in the country, there has to be some uniformity about quality of processes and products, both processes and products. So for that, a country-wide standardization is necessary. This is true with every country. So in India, we are having an institution called as Bureau of Indian Standards, BIS, Bureau of Indian Standards. So what is the meaning of this? Just let us understand. The Bureau of Indian Standards, abbreviated as BIS, is a statutory national standards body working under Government of India. You can see here. So Bureau of Indian Standard is a national standards body of India. Its main office is located at New Delhi, the capital of India. You can see that building here. This is the logo of the BIS. This is the logo of BIS, and Manakaha Pathapradarshakaha, a Sanskrit phrase is there, which is the tagline Manakaha Pathapradarshakaha. Here you can see the website address for this bis.gov.in, and here you see the ISI mark, Indian Standard Institution mark. We know that whenever we find this mark on any product in the market, we can be assured that it is having a particular quality. So this is a mark of assurance of quality. So this is how the standardization is done by the Bureau of Indian Standards. Now what the Bureau of Indian Standard is doing for our engineering processes? Indian Standards codes. So what the Bureau of Indian Standard doing is, it is publishing books or booklets which are called as Indian Standard or IS codes. So these IS codes are the books published by the BIS on the various technological areas to lay uniform nationwide standards of quality. So whether it is reinforced concrete, you will have one booklet called as Indian Standard for the reinforced concrete. You will have another standard for steel structures. You will have another standard for manufacturing of cement. Hundreds of such Indian standard codes have been published, and they are not only published once by the BIS, they are continuously modified, upgraded and revised. Just like India having BIS, every country has its own institutions like BIS or Bureau of Indian Standards, and the codes of standards also for that particular country. For example, BSI, British Standards Institution. This is the Standards Institute for the United Kingdom. You can see that BSI is its long form, or is its abbreviation, and its tagline is also interesting: making excellence a habit. Making excellence a habit is the tagline of BSI. Having understood the meaning of Bureau of Indian Standards, its significance, its importance, and also having understood that there are Indian standard codes for every area of engineering, design and construction, we will now go to IS codes related to RCC structures, because we are studying RCC structures. So we will now go through a list of Indian standard codes related to RCC structures. This is in short the cover page of the Indian standard code which we use. It is having Hindi version as well as English version, particularly only on the cover page. Inside it is in obviously English. So the first Indian standard code for RCC structures is IS 456-2000. This, you know that this number is a typical number. Indian standard 456, this 456 is a code which is directly related to RCC structures. So this is unique with the particular area of engineering. So IS 456 is related to uh, RCC structures. 2000 is the year of publication of this IS code. So the title of this IS code is Plain and Reinforced Concrete Code of Practice. Up to Amendment 5 in July 2019. As we said right now, the code was published in 2000, but in July 2019 there was fifth amendment. So there were 4 amendments in between since 2000 to 2019. So we can say till July 2019 this IS code IS 456-2000 has been amended 5 times. Okay, so this indicates that the IS codes are constantly updated, and the engineer, while designing a structure, has to be updated about the latest version and latest amendment and revision of the particular IS code. The second IS code is IS 875-1987. It is having 5 parts. This code is of help while designing using IS 456. So this code is about code of practice for design loads other than earthquake for buildings and structures. So this code has got 5 parts: part 1, part 2, part 3, part 4, part 5. The part 1 is about dead loads. Dead loads are the unit weights of the building materials and components. About 72 building materials and components are considered for their unit weights, their self weights. So these are some standard values, say brick masonry or stone masonry or concrete or reinforced concrete and so many other things. There are 72 building materials whose self weights and the form of unit weights, kilonewton per meter cube, have been given in this part 1 of IS 875. Part 2 is about imposed loads or live loads. The live loads come on the structure because of the users, the weights of the users. They are other than dead loads, and the usage of floors and roofs and dust and rain and impact and vibrations. All these loads are other than the unit weights of the materials. So they are categorized as imposed loads. Okay. Dead loads are self weights, whereas imposed loads are the loads which are put above or put over the dead loads. So that is part 2 of IS 875. It gives us the exhaustive data about the imposed loads. Part 3 is wind loads. We know that wind is a natural phenomenon and it has a great impact on the structures. It exerts pressure, wind pressure on the structures, and in that case it is necessary to study the wind loads in absolute detail. And the fourth is snow loads. Snow loads are related to the areas where the snowfall is a common phenomenon, and you have to take the loads due to the snowfall also. So IS 875 part 4 is about snow loads. Part 5 is about special loads and load combinations. You have to use the combinations of these loads. These loads will act simultaneously. Sometimes simultaneously, sometimes only 2 will act, sometimes all the 3 will act, and so on. So IS 875 part 5 gives us how to do the load combinations of the various loads and what are some other special loads. So this is about IS 875 1987. Of course, it is reaffirmed in 2008 and all that. It was first published in 1987. It is having 5 parts, and all the 5 parts are related to dead load, imposed load, wind load, snow load, and special loads. So we have to take help while using IS 456-2000. We have to take help of IS 875-1987 also whenever we are taking decisions about the loads on the structure. Then the third is IS 13920-1993, reaffirmed in 2003. This is related to ductile detailing of reinforced concrete structure subjected to seismic or earthquake loads. This is code of practice for that. So ductile detailing of reinforcement. The steel bars, the way we provide them inside the concrete in RCC, the bars are to be properly detailed. Okay, their lengths, their spacings, and all these detailing are requirements, they are to be also considered from earthquake point of view. So ductile detailing for earthquake is specially considered in IS 13920. Otherwise, IS 456-2000 is already giving us various rules and laws for the detailing of reinforcement. But ductile detailing for seismic forces is to be considered again separately. So we have to take help of this IS code also. And there is last publication in this part we will see, that is SP16. This is also a publication of the Bureau of Indian Standards, and this is about design aids for reinforced concrete to IS 456. So what they have done is, in this SP16 they have explained the clauses of IS 456-2000 in a greater detail. They have provided a very good guide book for IS 456-2000. So all those who want to go into the depth of the provisions of IS 456-2000, they can refer to SP Special Publication 16 for design aids for reinforced concrete to IS 456. So friends, this was a brief overview of importance and significance of the Bureau of Indian Standards and the relevant Indian standard codes used for RCC structures. Now in the third part of this video lecture, we have to undergo a formative evaluation. So pause your video and write on a paper the answers of the following questions. I am going to ask you 3 questions on the contents which we have watched up till now in this video lecture. The first is, describe in brief 4 basic elements of the field of civil engineering, which is the fourfold role of a civil engineer. So this is an understanding level question. Second is, describe the role of Bureau of Indian Standards. Describe the role of Bureau of Indian Standards. So this is also an understanding level question. And the third and last question in this formative evaluation is, enlist and download the Indian standard codes relevant to RCC. So these are the 3 questions. If you have given enough attention to these 3 questions, you can continue for the video. So friends, here we come to the last part of this video lecture, summing up. Let us conclude what we watched in this video. This is lecture 1.2, structural design and IS codes. The expected learning outcomes from this video, as we talked in the beginning of the video, are 3. 1. To describe fourfold role of a civil engineer. Second, to appreciate significance and role of Bureau of Indian Standards. Third, to know the IS codes relevant to RCC. So just revise to your mind and find out whether you have really attained these learning outcomes or not. If not, you have a choice of going back and watching the video and again till you are confident about these 3 points of this video lecture. We also used some key terms in this video lecture: planning, structural components, structural design, rehabilitation, BIS and IS codes, IS 456-2000, IS 875. These key terms or key words are like anchor points, and you can anchor your understanding of the content in your mind using these key terms. That means if you just recollect in your mind the meanings of these key terms, you can revise the entire video lecture just by the help of these key terms. So do that exercise, it's quite useful. Contact your teacher for any doubts or queries. And finally, the summative assessment quiz is there. Attempt the online summative assessment quiz which is provided by the teacher. Now you know I provide the multiple choice 20 question Google quiz. So do attempt that quiz. This quiz will be, the link of this quiz will be available in the description under the YouTube video of this video lecture, and you can very well attempt. that quiz. Now here is Smarty back for us to say thanks. So thanks all for watching this video, and goodbye till we meet in the next lecture.